Topic 7-2, Pythagorean Triplets and the Converse of the Pythagorean Theorem. Note in red the Holt reference pages that you can find this in the textbook. Okay, we're going to start with what we've previously learned about two sides of a right triangle, that the third side can be found using the Pythagorean Theorem. Pythagorean Theorem states that any group of three possible integers, a, b, and c, such that you square the c and it would be equal to the other two legs, a squared plus b squared. This is known as the Pythagorean Theorem. So an example that we often see, actually even tested over a lot, is the Pythagorean Triple. They call it a triple because these numbers will always work. If you square the 3 and add it to the square of the 4, it will always be the square of c, and make note that c is always the largest number. So when you're trying to classify, you're always going to make your c the biggest number that you have. So this one's always going to be the longest side. So remember that. So we would go ahead and note that 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 is equal to 25. Therefore, we just state that 9 plus 16 is 25 is equal to 25. And therefore, yes, this is a Pythagorean triplet. A lot of times this is visualized. The textbook has this, a picture of this actually on page 352 in your textbook if you'd like to look at that. So some other triplets, factors of these numbers. So this is the first triplet that you can name, a 3, 4, 5. So if you multiply other triplets, there's multiples of any of these. 5, 12, and 13 is another Pythagorean triplet. 8, 15, and 17 is another Pythagorean triplet. And 7, 24, and 25. And any of the factors of these numbers. If I multiplied 2 times 3, 2 times 4, 2 times 5, you would get a 6, 8, 10. So that would be another triplet. So just thinking about multiplying any number by each of these and you would get a triplet. But look at the textbook for the visual of what those would look like, and we're going to do a few examples here in a minute. Alright, make sure you fill this one in. Recall that given three sides, a triangle can only be formed if the sum of the two shorter sides is greater than the third side. We had done some examples of this with our snap legs, and I'm just going to show a few right here. If I have the longest side being red, the other two, orange and purple, added together would have to be longer than that red in order to form a triangle. So you notice that I cannot snap these together unless I bend it, and it would snap apart. So this could not form a triangle because any of the two shorter sides would not be longer or greater. You got to remember that it's got to be greater than. Another example could be this one, where these two purples would actually equal, the two shorter sides is actually equal to the longest side. Therefore, I cannot make a triangle out of it. Okay, so some examples of triangle lengths. Let's just look at, now that we've seen a visual, the longest side here is a 6. So adding together 4 plus 5 would have to be greater than 6. Well, 4 plus 5 is 9, so yes, this would work. That would form a triangle if I had measured lengths of those sides. What about 4, 5, and 9? Well, that would be the example of the 2 purple and the red, because 4 of the snap sticks that I had, 4 plus 5 is 9, and it cannot be equal to 9. So this would be no. It would not work. You cannot form a triangle if the 2 shorter sides equal. And also 4 plus 5 being 9 is definitely less than instead of greater than 10. So this would also be no. They could not form triangles. So make note of that, and let's move on. Recall that one of the classifying triangles by its angles, and a triangle could either be acute, obtuse, or right. If a triangle can be formed, you can determine the type of triangles formed by comparing the squares of the longest side C to the sum of the squares of the shortest sides A and B. So let's just put the formulas down for this, that if you use the triplet and square it, if it's equal to the A squared plus B squared, you're going to get a right triangle. If you square the longest side and it's less than adding the other 2 legs together after squaring them, if it's less than, then it's going to be an acute angle. An obtuse angle is going to be formed when that side is greater than the square of the other 2 shorter legs. All right, an example, a visual of seeing this, if you want to ask your teacher for the these snap legs, look at this one. This is actually an acute triangle because all of the angles inside this equilateral triangle, because they're all green, they all exactly have measures of 60. And 60 is smaller than 90. Remember, acute is smaller than 90. So this would be an example of an acute triangle. Another example of an acute triangle could be this one. All of these angles measure, well, you would think of these 2 shorter sides, this being the longer one. The side opposite would be your C. So if you squared this side, it's going to be less than the square of this angle and this angle. And then another converse of that would be this angle here would be represented by your C. And if I squared the measurement of side C, which is opposite the largest angle, these are my 2 shorter legs, the square of these 2 angles opposite those, if that is an angle greater than, it's going to be an obtuse angle. A good picture of this in your whole textbook is on page 351, if you want to see that. All right, let's do some of these examples here. Determine if a triangle can be formed first and then classify it. Classifying meaning to say whether it's a right, acute, or obtuse. Well, the largest side here is your 12, so this is going to be your C. So if this is the largest one, these 2 have to be greater than. Well, 5 plus 4 is less than 12, not greater than 12. So this one's no, it cannot be classified as a triangle at all. It's not a triangle. But let's look at this. If we're trying to classify right, acute, or obtuse, we're not just adding the 2 sides together. Well, first we got to see if it can be a triangle, so we will add the 2 shorter sides to see if they're greater. Well, 6 and 7, 6 plus 7 is definitely greater than 8, so it can be a triangle. So we're now going to square the 2 shorter sides. 6 squared plus the 7 squared would have to be, well, what are we trying? We're going to say whether it's greater than, equal to, or less than the square of 8 squared. Well, 6 squared is 36. 7 squared is 49. What is this added together in relation to what 64 is? Well, if you add these 2 together, you're going to get 85. and 85 is greater than 64. So if the measure of these two sides is greater than the third side, I wrote it a little bit backwards. These are my two shorter sides. But if it's greater than, this is classified as an acute angle. Okay, so first you're just deciding whether it can be a triangle. So use your calculator and determine what the square root of 10 is. That's approximately 3.162. So that actually is larger than these two, so you would be adding the 1 plus the 3. 4 is definitely greater than the 3.162, so yes, it is a triangle. So we move further into classifying it by squaring the two. Let's go ahead and put, since I put it this way over here, we're going to put that the largest side, the square root of 10, but remember we're taking that and squaring it for classification. What is that in representation of 1 squared plus the 3 squared? Well, that would be 1 plus 9, which is equal to 10. And be real careful here. We're still trying to decide what's going to go greater than, less than, or equal to. And the square root of something squared, well, this squared would be square root of 10 times square root of 10, which is 100. And the square root of 100 is 10. So we find that this is actually equal. And when they're equal, we classify that as a right triangle. Okay, last one. They're using all radicals, but if you want to get approximations, this is 3 and this is 4. So 3 plus 4, and the square root of 27 is approximately 5.2. So 3 and 4 is 7, so that's greater than. So yes, it is a triangle. Classify it by squaring. Well, the square root of 27 squared, square root of 27 squared is just 7. Well, what is that in relation to 3 squared plus, oh, I'm sorry, we already got the square root of 9. Square root of 9 squared is just 3. Square root of 16 squared is just 4. So you're taking just the square roots. Oh, I'm sorry, we are squaring each of these, because this is 3 and this is 4. So you are going to use these formulas to determine which one it is. 3 squared is 9, 4 squared is 16, 16 and 9 is 25, and that is less than 27. Remember, we were just trying to figure out which one it would be. So this is classified as obtuse, because the largest side squared was greater than the other two added together. But again, refer to the textbook or ask your teacher if you need further help with these before moving on. And that is 7-2.